Hi, it's Andriy, and this is Android developer course, which the first part of the developer course, where we are discussing some basic Kotlin concepts. And today is chapter 1.7, which is objective-oriented programming and data classes in Kotlin. So first of all, we are going to talk about objective-oriented programming. So we basically don't need to link to some language. So we have many objective-oriented languages, which at least languages which are using this concept. And the most important thing which you need to understand about objective-oriented concept is that everything is object. So imagine the world around you, and every single thing which you can see, which you can interact with, is an object. So this philosophy can help you understand objective-oriented principles better. Well, and there are some things which are describing this objective-oriented principles. So there are like four main components or four principles. And here they are. So the first one is encapsulation. Second one is abstraction. The third one is inheritance. And the fourth one is polymorphism. So we will discuss every objective-oriented principle on example. And first one is encapsulation. So what is encapsulation? Encapsulation is basically it's about privacy. So imagine this ATM machine, and we have a simple interface to enter the PIN code, to receive money, to check some amount of money which we have on our credit card. And there are lots of different operations which are happening inside this machine, and we never know what exactly happens. And this is about the privacy. So the same way in the encapsulation. Some of our object can perform some complex, important jobs, and the consumer, the user of this object, will never know what is happening inside this machine. And let's jump into the code example. So we have our Kotlin playground, and yeah, we can just basically create ATM. Yeah, like this. And this ATM will have some functions like enter PIN, function get money. Probably we would need to give some amount in int, and I think yes, that's and for instance end operation. So this is the public API for our ATM. So I said before that encapsulation is about privacy. So in order to make a private operation inside ATM class, we need to use keyword private. But before that, I just wanted to create ATM object, and I can call enter PIN. I can call then ATM get money. like 100, and I can call ATM and operation in the end. So pretty straightforward. So for now we just only have the public API, which is enter pin, get money, and end operation. What actually happens when we enter pin? Yeah, entering pin has to be some pin, right? Like, I don't know, 1, 2, 3, 4. Yeah. So when we enter pin, we probably should validate it. So there will be another function which is already private, because nobody should know how we validate our pin code. And validate pin is our first private function. And here we also pass the code. Probably we can return some boolean, and we can return, I don't know, let's imagine that it's always true. So return true, that our pin code is valid. But here I'm not doing any implementation, just writing down that here validation logic happens. So this one can be really some complex stuff, like, I don't know, network request to some secret servers of the bank where they verify by card the validity of the pin code, because it's really sensitive information and nobody can get access to this API, track it. So that's why, yeah, it has to be private, and we just do validate pin. Yeah, and we validate it. If our pin is not valid, we just throw exception that the pin is not valid. Something like this. Pretty simple thing. About to get money. So we ask for 100 money. We probably need to validate if user has enough money on the bank account. This is also private API. This is API which nobody should know about, which nobody should access to, and we need to validate amount. And also let's return boolean, and here I will just simply return some, I don't know, amount int, that our amount is less than 100. If it's more, then we can also do here, here, if validate amount so amount is not valid, we throw an exception that sorry, it's a string, you don't have enough money. So yeah, that's basically it. I will not run this code because we don't print anything. You just can read what happens here. And yeah, basically these three functions, enter pin, get money, and end operation, are the public interface, public functions, which user of the ATM can access and execute. But if you try, for instance, do the validate pin here, yeah, I will run this code. Let's see what's gonna happen. Yeah, it's unresolved reference because validate pin is private function and nobody can really access this function. Let's run it again. Yes, it's still compile error. It's just silly thing. I forgot to write fun keyword. Yeah. Nothing is compiling without fun. You should remember that. No value passed for parameter code, and we also, of course, need to pass it here. Yeah. Now it's executing, but nothing is happening because we don't print, and yeah, our program is just straightforward. So as I said before, we have a public functions and we have a private functions, which basically describe the encapsulation. So validate pin and validate amount. These are the part of the class, of the ATM class, which are encapsulated. You can use this term in conversation with other programmers. So if people telling you that you need to encapsulate something, this means that you should make it private. Next principle is abstraction. So it's interesting principle and interesting picture we have here. But I have a question for you before. Can you imagine animal? So what is the picture of in your head when I say animal? So it could be your favorite animal, it could be some random furious animal, or it could be a human because we are also animals, whatever. So in our world there are some things which you cannot create. I mean, there are lots of different animals, but you cannot imagine word animal as an object, as something you can touch. So the abstraction is about that. So there are some things in our world that they are abstract, like animal. And that's why I'm going to make another code here. Yeah, let's remove the ATM for now. We don't need it. And we'll create our first abstract class. And I will call it animal. We have constructor here and name. And we also have an abstract function. Don't forget the word fun. No, it's make sound, which will return string. Yeah. So what is important about abstract class, that you cannot create an instance of abstract class like this. So I'll try, okay, no, animal, and try to compile this. It's not a compilable because cannot create an instance of abstract class. So why we then need those abstract classes? We basically need them to create another classes. And this story actually describes abstraction principle and inheritance principle in the same time. So we have, for instance, class dog, which extends animal. So this 2 dots means the extension, and our dog has a name. We pass this name to the animal constructor, and we need to implement this make sound function. So for that we would need to use override annotation, and we do fun make sound. So if we have abstract function, this means that we basically need to do implementation in every child of the animal class, and for this we need a woof. Let's copy paste this, create a cat, and cat makes meow. So this is an abstraction actually. Now we can create our cat, dog, I don't know what's the perfect name for dog. Jack. I had a dog. His name was Jack. Cat. I don't know, it's so difficult. It's even more difficult to name variables. We had a cat kappa. Okay. Yeah, this code is gonna be executed. Still nothing is happening because we don't print anything. But yeah, this is about abstraction. We cannot create an object of the animal because animal itself is an abstract thing. But we can create object of the dog, of the cat, of any other animals. So dog at least we can imagine. Something you can imagine means that you can create an object of this. And this is about abstraction. Next principle is inheritance. So we already touched it a little bit. And here is the example like a family tree. So this is the perfectly describing the inheritance principle. So we all inherit some qualities, some things, some properties, so to say, from our parents, grandparents, and many relatives we have. The same thing happens in programming. And here, as a code example, I will jump directly into the cat, dog, and animal thing. And inheritance, for me, looks pretty similar to abstraction. And this line in particular means that we inherit animal. But abstraction is about a different thing. It's about some classes or interfaces which you cannot imagine, which are abstract. And I described to you before what abstract means. But what if we give another layer of inheritance now? If we want to make our class inheritable, we need to write open in Kotlin. This means that our dog can be extended, inherited. Now we create another class called shepherd, which also has a name. And originally shepherd is a dog, which we write down here. Yeah, so the shepherd extending inherits all of the qualities of the dog. So shepherd can bark, make sound woof. But also, let's imagine dog has some more properties, and for instance, we have open val speed. Oh. Yeah, like this. And default speed is 20 kilometer per hour, meters per second, whatever. And now for the shepherd, we can override the speed. Shepherd is a bit faster. The difference between abstraction and inheritance is that we still can create instance of the dog class. We can imagine dog. But in the same way, we can create an instance of dog shepherd using this constructor jack1. And this is it about inheritance. So inheritance means that we can inherit other classes, inherit their properties, functions, override them and use them. This is about inheritance. The last and not least principle of objective-oriented programming is polymorphism. So polymorphism from Greek means many forms. Polymorphism is the ability to present the same interface for different underlying forms, data types. And in objective-oriented programming, it allows methods to do different things based on the object is asking upon. This is achieved by method overloading, method overriding, and polymorphism actually enables flexibility, scalability in programming. So it's a bit difficult to explain, but in code you already saw the overriding things, but I will show you now how polymorphism works. Surprisingly, we can use the same example with animals. I think it works just perfectly. Imagine you have a function. So function which will be animal does sound, and we passing here object animal. We're not creating object, we're just passing it. So, and here we're going to print as our animal already has a name here, see, and the make sound function. So we can access this name and make sound for our animal. Yes, I'm using string literals. Name makes animal make sound. Yeah. Just let's be sure that it's compiling. Yes, it is compiling. And now we have to execute this function. Animal make sound, we pass dog, we pass cat, and let's pass the dog, shepherd. Yeah. Now actually we will receive some print message. So Jake makes woof, Kappa makes meow. Let's do the println for better output again. Yeah, Jake makes woof, Kappa makes meow, Jack1 makes woof. So, but here you see that we are not passing cat or dog or shepherd dog, we're passing the animal. And polymorphism helps this implementation realize which object is used. Was it a cat, was it a dog, or was it a shepherd dog? So this is the polymorphism. Our animal can take many forms as it could, and this principle realizes what was the animal passed to this function. And this is it about the polymorphism. So we finally described all of the objective-oriented principles, and now we have another small topic which is called data classes. I think this is the last essential Kotlin principle we would need in our Android course. And here is the quick code example of data classes. Finally, we can remove our animals and use some other example. Data class is a special class that is primarily used for holding the data, obviously. And convenient thing about Kotlin data classes, there is no such thing as data class in Java, is that it already overrides some functions which you can conveniently use later. So let's do the code example. Let's think that we have a data class called user, and this user has a name and this user has age. The important thing about data class, it doesn't have functions, so it just keeps and holds the data. The class, which is more or less abstract, but you still can create an instance of this class, so it's not abstract. And here in Kotlin you can also inherit data classes, and you can basically try yourself to recreate our animal hierarchy using Kotlin data classes. Could be interesting thing, obviously without functions, but anyway, yeah, you can try it. Could be as a technical task for this lesson. I didn't plan to create anything specific, but yeah, if you have time, if you want to do this, if you want to play with objective-oriented principle concepts in Kotlin in this playground, you can do it. So let's think. We have a John. His age is 30 years old. And we have the same user. Not the same, but user 1. And let's print. And we ask the question: is user and are user and user 1 same? And the answer is, let's use the string literal, user equals user 1. Let's try to execute it. Yeah. Question is, are user and user 1 the same? Yes, they are the same. So it looks obvious, they have the same name, they have the same age, but what is interesting about this message? Because for instance in Java you would need to override some specific functions if you want to compare objects. So in order to compare user to user 1, we use equals function, and in Java you would need to override equals and hash code functions to be able to execute this equals function correctly. So you can basically compare two objects only after you override equals and hash code. In Kotlin you don't need to do this, we have data classes for that. So this is the main concept of data classes, and I believe we will use it a lot in Android. And I just wanted you to congratulate that we finally finished the Kotlin basics, and now I believe we are ready for real Android, and I hope that this knowledge we had will help you in future in Android development, and you can always come back if you have some difficulties, troubles, you don't remember how to create a map, how to create a list, how to operate them, or you forgot about the encapsulation or about inheritance. You can always come back and see these lessons again. For now, I will just ask you again to subscribe to this channel. It would be super great for me. It's the biggest thank you I can imagine. As I want to remember you that this course is going to be free. Yeah, so I hope you like it. I hope you will stay with me, and we will continue our journey to Android development. And yeah, see you in the next lesson.